class, section 5.4 and 5.5 are about the graphs of our 6 trigonometric functions. So let me go ahead and introduce them all to us. So first off, here are the domains and ranges of trigonometric functions. Remember that the domain, hi Bobby, remember that the domain of our sine function is going to be all real numbers. That's because sine is y, right, if we're looking at our unit circle. So it's never undefined. And its range goes from all real numbers from -1 to 1 inclusive. So remember, sine is y, so sine can take on values of 1 to -1 if we're looking over here at the unit circle. Cosine is x, right? So it can take on all real numbers because it's always defined along the circle, right? That's where we get our values from. Cosine theta is x, y, right? Tangent of theta is y over x. So its domain is all real numbers except odd integer multiples of pi over 2. That's because at pi over 2, which is 90 degrees, and -3 pi over 2, which is positive 3 pi over 2, which is 70 degrees, 270 degrees, we would be dividing by 0 because x is 0. Cosecant, 1 over y, is all real numbers except integer multiples of pi, and that's because integer multiples of pi, like 2 pi or 0 or pi, we have y is equal to 1, so we'd be dividing by 0, which is undefined. For secant, which is defined as 1 over x, we would be dividing by its domain is all real numbers except odd integer multiples of pi over 2. Again, we're excluding values where x is 0, so that's at 90 degrees, 270 degrees. And last, cotangent, which is x over y, is all real numbers except integer multiples of pi, so where our y value would be equal to 0. Now remember, we could think of these, cotangent, tangent, cosecant, and secant, as rational functions, right? And when I have a value that is undefined, that's where I get an asymptote. So a couple of things to keep in mind. So let's take a look at the sine function. Sine of theta, which is 0 degrees, right, is going to be 0. And we get this from our unit circle. Sine of pi over 6, which is 30 degrees, is 1/2, right? We're taking the y value because sine of theta is y on our unit circle. So be really comfortable with your unit circle. Pi over 2, so sine of 1 was going to be 1, right? We're taking the y value. Sine of pi is going to be 0. And sine of, say, for instance, 3 pi over 2 is going to be 1 because that would be the y value on our unit circle at this angle, okay? Like I said, its domain is all real numbers and its range is -1 to 1. It is odd, right? It's an odd function that tells us something about it. That means that f of -x equals -f of x, right? That's odd. Our period is 2 pi. That's how it repeats itself. It repeats itself every 2 pi, right? Goes through the full cycle every 2 pi. And its amplitude, which is half the vertical distance from our maximum height, right? This has a maximum height of 2, right? Because we go from 1 to -1. So my amplitude is 1, which is half of that. And it's going to have an x-intercept at every integer multiple of 2. Here's how our graph is formed, right? It's formed by taking the y values as we go around the x-axis. There's lots of really cool interactive GIFs out there for trig. Now let's take a look at the graph of the cosine function. So this looks a lot like the sine function, I know, but here's the difference. When cosine of theta, when theta is 0 degrees, cosine is 1, right? We're taking the x value. So whereas cosine starts up here, sine starts down here. This is where sine starts. So that's the difference, right? But they do follow the same path and take on the same values, just their x values are shifted. So if we look at our unit circle, again, that's where we want to live. We want to live on the unit circle. When x is 0 degrees, its y value is 1. When x is pi over 2, its y value is 0. When x is 3 pi over 2, sorry, its x value is 0. When x is pi, its x value is -1, right? We're thinking about the unit circle. I've got pi, which is 180 degrees. This is the value -1, 0, so x is -1. That's where this value comes from. And at 3 pi over 2, down here, again, our x value is 0. So its domain is all real numbers. It is an even function, so f of -x equals f of x. Yes, that's exciting, Bobby. Its period is 2 pi, so it repeats itself every 2 pi. It has an amplitude of 1, just like sine, but its x-intercepts are going to be all odd integer multiples of pi over 2. Okay, let me write that down. Let's do odd integer multiples of pi over 2. And it doesn't cross at 0, right? So let's get rid of that. That was a typo. Odd integer multiples of pi over 2. Here's our tangent function. Remember, tangent function is undefined at odd integer multiples. So that's why we have all these asymptotes, right? At these odd integer multiples. Tangent of theta, if we're back on our unit circle, is y over x. So whenever our x is 0, we're going to have an asymptote. So its domain is all real numbers except odd integer multiples of pi over 2. Its range is all real numbers, and its period is pi. Its x-intercepts are all multiples of pi, and its vertical asymptotes, again, are at all the odd integer multiples and 0, right? No, not 0. Odd integer multiples of pi over 2. The cotangent function, very similar, but remember, cotangent function of theta is x over y. So here we're undefined at even multiples of, at multiples of pi, because pi, when x is 0, when our theta is 0 or our pi is 0, right, we've got our y is equal to 0, right? Its range goes from negative, and then its range goes from negative infinity to positive infinity. The functions that look the weirdest are our cosecant functions and our cotangent function. Remember, cosecant of theta is 1 over y. So when y is 0, we're going to have asymptotes. So that's when, we're at 180 degrees, 360 degrees, right? When we're on our x-axis of the unit circle. So we're going to get asymptotes. Its domain goes from negative infinity to positive infinity, but does not equal integer multiples of pi. And its range is when absolute value of y is greater than or equal to 1. We could also write this as negative infinity to 1, negative 1 inclusive, union 1 to positive infinity, if you wanted to write it in interval notation. Here's our secant function. Again, secant of theta is 1 over x. So whenever our x value is going to be 0, which is at like 90 degrees, 270 degrees, that's when we're going to have an asymptote. Its domain, as long as x doesn't equal odd integer multiples of pi over 2. And its period is, just in case you wanted to know, its period is 2 pi. The same thing is true for cosecant, right? Its period is 2 pi. For tangent, cotangent, secant, and cosecant, they don't have an amplitude, right? If it goes on to infinity, their amplitudes are undefined. Only sine and cosine have an amplitude.